Example number 7, we're going to go ahead and use some real life data. This is really cool. I really like these problems because we could just show that math can be used in real life. Don't try to creep. Here we go. So example number 7, the number and thousands of employees in the cellular communications industry in the United States increased in a linear pattern from 1998 to 2001. And they say to see the figure. So here's in 1998 right here, and then in 99, and then 2000, and then 2001. So they're saying it's like see how like it looks like a line right here if you were to connect the maximums here. So that's what they mean by they're saying that the number of employees in the cellular communication industry fit a linear pattern. Okay. But then in 2002, the numbers dropped, then continued to increase through 2004 in a different linear pattern. So that's why it dropped. But then look, now it's another line right here. And so our problem gives us this. It says that these two patterns can be approximated by these two functions right here. So we're given where our time is from 2008 to 2011. They tell us that this right here, this is the equation of that function. And then they say from 2012 to 2014, that's the equation of that function. And what do we call this again? A piecewise function. Okay, so it's when your function n is defined in pieces. And by the way, we're going to get to some functions where it's in pieces of like 5 pieces, 4 pieces. It's really neat. So the graph looks all weird when you graph them all together. Okay, so what we want to do is that it says I'm using this information, uses information to approximate the number of employees for each year from 1998 to 2014. They want to know how many employees were there in 2008 or in 1998, 98, 99, 2000, 2001, and so forth. So basically, look, if you go up this bar graph, see right here, they want to know right here, it says number of employees. So basically, they just want to know what is this number. And then in 1999, what's that number? And then what's that number? Now, we could obviously approximate right now by just doing it. That looks like 100 and maybe like 30, 132. I mean, I don't know. I'm just guessing right now, but I mean, it obviously has to be between 125 and 150. But it didn't say guess. It says actually, let's actually find from our piecewise function. Okay. So check this out. And I'm just going to start the process, and then I'm just going to write all the answers down because this is a lot of calculation work. But the idea is, do you understand how to use real life data, and now can you actually produce what they want here? So let's think about this. What happened? How many employees were there in 1998, right? Isn't that what they want? They want from 98 to 2004. So watch this. So that means that our t is equal to 8, right? Because they tell us that where t corresponds with the year, where t equals 8 corresponds with 98. Okay? So where t is 8, doesn't that mean that we're going to fit right here, right? That means if I want to know what happens at 1998 or at t is 8, I'm going to go this formula. So that means I would do 23.5 times 8 minus 53.6. Okay, you would bust out your calculator, do all those decimal works, and we would get 134.4. So this number right here actually was 134. 134.4. So I was kind of right. Like I said, 130, 132. So that's what that is right there. So basically, they want you to go from 98 to 2004. So what about in 1999? Well, that means that my t equals 9. I have to plug in 9 now. 23.5 times 9 minus 53.6. Okay. Put all that in your calculator. 157.9. And obviously, you're just going to keep going on here. I mean, this thing's going to be kind of tedious. So, like, you'll do it for 2000, for 2001, for 2002, 2003, and then for 2004. Let me just make one note real quick. Okay, and I'm going to just put the answers. I'm not going to do all this work right here because it's very easy. All you do is plug it in. Notice what happens after 2011. So going from 2001 to 2011, See, when you use this, when you get to here, you start to plug it in now to this one. You see, because now we use this function because now our t is in between 12 and 14, because this right here is our t is 12, our t is 13, and our t is 14. Okay, so just make that note right there that you need to plug it into the correct formula equation in order to get the right values here. So I'm going to go ahead and give you the values at each year. So in 2000, it was 181.4. And again, that's in thousands, right? I think that's what we're doing. This is what it says. Yeah, in thousands. In 2001, it was 204.9 thousand. Okay. And by the way, this is real life data, by the way. That's why when they say here's the source, meaning that this was real life data. So I think it's kind of neat that we can use real life data and we actually can do this kind of stuff here. All right, in 2002, 191.2, so 191.2 thousand, so or 100,000 there, or actually just thousand. In 2003, 208, 0, and 2004, 224. Oops, sorry, and so that was 224.8, and I guess that's going to be it right there.